Betelgeuse, the red supergiant star located on the shoulder of Orion's constellation, has been exhibiting behavior that has captured widespread attention. Its fluctuations in brightness have sparked speculation about an imminent supernova explosion. The question on many minds is, when will this happen? While no one can predict the exact time, experts believe it could occur in the near future. Join us as we delve into the latest developments regarding this fascinating star. If you want to stay updated on space news and cosmic phenomena, make sure to subscribe to our channel, like this video, and turn on the notification bell. Although you may not know it personally, you've likely noticed Betelgeuse, the bright red dot in the constellation Orion. Betelgeuse is immense. In fact, if it were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This massive and easily visible star continues to intrigue astronomers. Due to its relative proximity to Earth, Betelgeuse is a semi-regular variable star, meaning its brightness fluctuates over time. As it nears the end of its life, it may eventually explode in a supernova. Recently, Betelgeuse's behavior has become even more puzzling, as its brightness fluctuations have become more extreme. These variations are being attributed to an event known as Great Dimming, which occurred between 2019 and 2020. As a result of this phenomenon, Betelgeuse, the closest red supergiant star to Earth, is now shining twice as bright as usual, lighting up the southern hemisphere sky in the early evening hours. This unusual behavior provides scientists with a rare opportunity to study the star as it transitions from a bright to a dim state. In fact, Betelgeuse has been showing brightness increases of more than 50%, and on May 20, 2023, a significant 142% brightness surge was recorded. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics notes that Betelgeuse is currently the seventh brightest star in the night sky, up from its usual position at 10th. If you're in the southern hemisphere, you can easily spot it by looking for it on the shoulder of Orion. Even in the northern hemisphere, Betelgeuse is visible as the days grow shorter. One of the most intriguing aspects of Betelgeuse is that it allows us to observe the final stages of a giant star's life, something that has never been possible in such detail before. By studying its behavior, scientists can gain important insights into the processes red giants undergo before they reach their ultimate fate as supernovae. It is speculated that, when the time comes, Betelgeuse could become so bright that it might even be visible during the day and cast shadows during the night. Eventually, Betelgeuse will explode, ending its life in a spectacular cosmic event. Considering its distance of about 650 light-years from Earth, we will have the rare opportunity to witness this massive explosion up close. Heidi Morris, a scientist at the Los Alamos National Laboratory and president of the Astronomy Club, says that the public's fascination with Betelgeuse and its changing brightness has been growing. Even ancient civilizations, including indigenous Australian and Greek cultures, observed the fluctuations in Betelgeuse's brightness thousands of years ago. Typically, Betelgeuse's brightness cycle lasts about 400 days, but currently it is changing much more rapidly, with variations occurring roughly every 200 days. This unusual behavior started after the star ejected part of its outer atmosphere with great force. While these brightness fluctuations are out of the ordinary for Betelgeuse, the big question remains: is the star on the verge of exploding? According to a paper by Andrea Dupree and other researchers from Harvard and the University of California, Berkeley, it is estimated that it will take 5 to 10 more years before Betelgeuse returns to its normal brightness cycle. The authors note that the star has not been the same since the Great Dimming event, showing unusual behavior in both temperature and speed of rotation. Betelgeuse still has a long way to go before it becomes a supernova. As a red giant, it undergoes a series of nuclear fusion processes, fusing lighter elements like helium into heavier ones such as carbon, oxygen, and eventually iron. The immense pressure in its core allows helium to fuse into carbon, and the process continues, forming increasingly heavier elements. Once this fusion process progresses, the core will collapse under its own gravity, leading to a catastrophic explosion, a supernova. This explosion could create either a black hole or a neutron star. Chemical analysis of Betelgeuse's atmosphere suggests that the star is in the early stages of this fusion process, currently fusing helium into carbon at its core. As a red supergiant, Betelgeuse has had a fast and intense life cycle. It is now nearing the final stages of this accelerated development. When it exhausts its fuel, the core will collapse, resulting in an explosion that could outshine an entire galaxy. The timing of Betelgeuse's supernova remains uncertain. According to Professor Peter Burke, an expert in supernova research at the University of Portsmouth, we currently have no method for predicting when a star will explode. He points out that, despite the efforts of astronomers, we still lack a reliable way to forecast supernovae. The unpredictability of this event is further underscored by the fact that humanity has not yet observed many supernovae up close, making it difficult to study them in depth. Given this uncertainty, it's unclear whether we will witness the awe-inspiring explosion of Betelgeuse in our lifetime. However, one thing is certain: when it does finally erupt, it will be one of the most incredible events in the cosmos. Scientifically known as Alpha Orionis, Betelgeuse stands out in the constellation Orion as one of the brightest stars visible to the naked eye from Earth. Its name, derived from the Arabic phrase Betelgeuse, meaning the hand of Orion, reflects its prominent position in the sky. Betelgeuse has fascinated astronomers and skywatchers for centuries, not just because of its brilliance and visibility, but also due to its unusual behavior and the possibility of a spectacular cosmic event. Located about 650 light-years from Earth, Betelgeuse is classified as a red supergiant, a stage in the life cycle of massive stars that precedes a dramatic end. Red supergiants are among the largest and most luminous stars, with Betelgeuse being a prime example of this phenomenon. It looks like you're presenting an in-depth narrative about Betelgeuse, often written as Betelgeuse in popular media, and its eventual transformation into a supernova. The content covers various aspects of Betelgeuse's life cycle, its variability, and the potential for a cosmic explosion. Here's a summarized and refined version of your text. Betelgeuse, the giant star's journey toward a supernova. Betelgeuse, one of the largest stars in our universe, is located in the Orion constellation and has fascinated astronomers for centuries. If placed at the center of our solar system, its outer edges would stretch beyond the orbit of Mars, making it a colossal presence in the night sky. The birth of Betelgeuse. The journey of Betelgeuse began millions of years ago when it formed from vast clouds of gas and dust in the Orion molecular cloud complex. As it coalesced, it ignited nuclear fusion in its core, fusing hydrogen into helium and emitting tremendous energy. This process, known as nuclear fusion, counteracts gravity and stabilizes the star, maintaining its balance. The red supergiant stage. As stars age and burn through their hydrogen fuel, their cores contract, and their outer layers expand, transforming the star into a red supergiant. Betelgeuse, having exhausted its hydrogen, is now in the late stages of its stellar evolution. This phase is characterized by increasingly unstable nuclear reactions and dynamic changes in its luminosity, making it a semi-regular variable star. This means Betelgeuse's brightness fluctuates, driven by convulsions and eruptions on its surface. These variations have been documented for millennia, with ancient civilizations like the Babylonians and Chinese noting the star's brightness changes. The mystery of Betelgeuse's dimming. In recent years, Betelgeuse has exhibited significant dimming events, notably between 2019 and 2020, when its brightness drastically decreased. This sparked speculation about an impending supernova explosion. The cause of this dimming remains unclear, with hypotheses ranging from internal processes like dust formation and temperature changes, to external factors such as interstellar dust clouds or interactions with a binary companion star. The imminent supernova. Betelgeuse is nearing the end of its life and is destined to explode as a supernova, an explosive event that occurs when a massive star collapses under its own gravity after exhausting its nuclear fuel. The supernova will release a tremendous amount of energy, producing heavy elements like carbon, oxygen, and iron, which are vital for forming new stars and planets. These elements will enrich the interstellar medium, helping to shape future generations of celestial bodies. The supernova will also provide valuable insights into the processes governing stellar deaths. Depending on the mass of the collapsing core, the result could be either a neutron star, a superdense remnant, or a black hole, a region where gravity is so intense that not even light can escape. The timing of Betelgeuse's supernova. The exact timing of Betelgeuse's supernova is uncertain, though estimates suggest it could occur within a few thousand years, or perhaps much sooner, within the next few centuries. Astronomers have intensified their observations using both ground-based telescopes and space observatories to monitor Betelgeuse's behavior. By studying the star's brightness variations, spectral changes, and structural properties, researchers hope to uncover the underlying processes behind these fluctuations and determine the likelihood of an imminent supernova. The scientific and cultural importance. Betelgeuse's impending demise raises intriguing scientific and philosophical questions. Supernovae play a crucial role in the cosmic cycle, dispersing elements necessary for life and the formation of new stars. The study of Betelgeuse's explosion could provide a deeper understanding of stellar physics, nuclear fusion, and the behavior of matter under extreme conditions. Additionally, it sheds light on the origins of heavy elements in the universe and the expansion of spacetime. Culturally, Betelgeuse has captivated human imagination for millennia. Ancient societies viewed it as a symbol of cosmic power, incorporating its fluctuations into myths, ceremonies, and calendars. Today, Betelgeuse continues to fascinate astronomers and the general public alike, inspiring both scientific inquiry and awe. Its unpredictable behavior has made it a key focus for citizen scientists, who contribute to ongoing monitoring efforts. Future observations and discoveries. With advancements in space telescopes, such as the James Webb Space Telescope, astronomers will be able to observe Betelgeuse and other distant stars in greater detail than ever before. These observations will help to unravel the mysteries of stars, galaxies, and the broader universe, addressing questions about the origins of life, the fate of the cosmos, and humanity's place within it. As we continue to explore and study these celestial wonders, Betelgeuse serves as a reminder of the ongoing mysteries and the vast beauty of the universe. Its potential for a spectacular supernova provides a unique opportunity to study the final stages of stellar evolution and the dynamic nature of the cosmos. This revision clarifies key concepts while maintaining the original information about Betelgeuse's life cycle, dimming events, and the potential for a supernova. It also emphasizes both the scientific importance of the star and its cultural significance across history.